In section 3, we have some more vocabulary to talk about, and the first term is population. Population is a set of units. Now, these units could be people or objects, transactions, or events that we are interested in studying. So the population doesn't always need to be a person. Okay, we think about people first, but we could be interested in foods people are eating, or cars people are driving, or scores for a sporting event. So there's quite a variety of topics that are included with population. The next term is experimental unit or observational unit. This is the object or person or thing or transaction or event about which we collect data. For instance, you might be interested in the test scores for students in a class. The population is going to be the students in the class, while the experimental unit is the actual test score. The next term is variable. The variable is a characteristic or property of an individual experimental unit in the population. Our next term, measurement, is the process we use to assign numbers to variables of individual population units. A census is used to measure a variability for every unit of the population, while a sample is a subset of the units of a population. Statistical inference is an estimate, prediction, or some other generalization about a population based on information contained in a sample. We can measure reliability of our inference, and that tells us how good the inference is. A measure of reliability is a statement, usually quantitative in nature, about the degree of uncertainty associated with statistical inference. So it's important when we are collecting data and making any kind of an inference that we do have a measure of reliability. Now, in this next table, we're going to talk about elements of descriptive statistical problems and elements of inferential statistical problems. The four elements of descriptive statistical problems include the population or sample of interest. So we must identify the population or the sample of interest. For number 2, we need to be able to identify one or more variables that are to be investigated. Number 3, there may be tables or graphs or some type of numerical summary. And last, we're going to identify patterns in the data. For inferential statistical problems, again, we need to have the population of interest. And once the population is identified, we're going to have one or more variables that we will be investigating. Number 3 says that we're going to have a sample of population units. Fourth, we're going to make an inference about the population based on information contained in the sample. And last, we need some measure of reliability for that inference. Let's try to use the new vocabulary now to make some identifications. For problem 3, we have to identify the population and the sample from the given description. It says for part A, the Gallup organization contacts 1,019 adult residents of the United States age 18 years or older and asks whether the events of September 11, 2001 were a life-altering experience. So the population of interest here would be all United States residents 18 years or older. So looking back at the description, it's pinpointing the 1,019 adult residents of the United States. So that would just be the sample. The bigger picture would be all U.S. citizens. So the sample is just that 1,019 residents in the poll. In part B, a quality control manager randomly selects 50 bottles of Coca-Cola that were filled on October 15th in order to assess the calibration of the filling machine. So the population of interest here would be all Coca-Cola bottles filled on October 15th. But more specifically, the sample we are interested in would just be the 50 Coca-Cola bottles selected. In part C, a farmer wanted to learn about the weight of his soybean crop. He randomly sampled 100 plants and measured the weight of the soybeans on the plants. So the population of interest here would be the entire soybean crop. More specifically, our sample involves just the 100 plants selected. So I hope you can see the difference between the entire soybean crop versus just the sample we are interested in. That would be the 100 plants selected. And finally, Part D. Every year, the United States Census Bureau releases the current population report based on a survey of 50,000 households. The goal of this report is to learn demographic characteristics of all households within the United States, such as income. So the population of interest here would be all United States households, while more specifically, the sample involves just the 50,000 households that were surveyed. In question number 4, we have a study of 163 patients with sleep disorders. A study of 163 patients with sleep disorders was conducted to find a link between obesity and sleep disorders. What is the population of interest? And finally, what group of patients constitutes the sample of this problem? So first we will identify the population of interest, and that would be the collection of all individuals with sleep disorders. So from all of those individuals, we find our sample is just the collection of 163 patients who were involved with this study. And reference number 5 deals with archaeology in Ireland. The archaeological site of Tara is more than 4,000 years old. Tradition states that Tara was the seat of the High Kings of Ireland. Because of its archaeological importance, Tara has received extensive study. And you can find more information about this. The reference is Tara, an archaeological survey by Connor Newman, Royal Irish Academy in Dublin. Suppose an archaeologist wants to estimate the density of ferromagnetic artifacts in the Tara region. For this purpose, a random sample of 55 plots, each size 100 square meters, is used. The number of ferromagnetic artifacts for each plot is determined. So part A, we're trying to identify the variable. So what do these archaeologists want to study? They want to know the number of ferromagnetic artifacts per 100 square meters. In part B, is the variable quantitative or qualitative in nature? In other words, if it's quantitative, something can be measured. There is a numerical scale that could be used. Or is it qualitative, where numbers or a number scale could not be used? So looking back at the variable, it says specifically the number of ferromagnetic artifacts. That is something that could be counted and a numerical scale could be used. So we know that our data would be quantitative in nature. And finally, part C. What is the implied population? So that would be the number of ferromagnetic artifacts per each distinct 100 square meter plot in the Tara region. So we just really added one more detail to our variable of interest, and that is to say where these artifacts are found. So the information is specific to the Tara region.